Hi guys, welcome to this quick video on how to create a custom steel baluster for your railing projects. So I'm in the default structural template from Autodesk Revit 2019. To demonstrate this, I'm going to draw in a quick floor slab, just the generic one. I'm going to quickly draw a rectangular shape, something that size is okay. And then I'm going to go to architecture and I'm going to put a standard railing. I'm going to sketch it. I'm going to use the default type that comes with the structural template. I'm just going to offset it inside my floor, and as I'm drawing I'm just going to click spacebar to switch the side, and I'm going to confirm that. So I've just drawn it. You will see that as default in the structural template it's not visible, so I'm going to go to my default 3D view, VG for visibility graphics, and just turn on the railing. Click apply, click OK. So weirdly, as a default, that is all that comes in on the default railing that's there. And that's just because there's no balusters configured. There is only really a top handrail. So I'm going to click the type, and I'm going to click edit, and I'm going to duplicate it, and I'm going to call it steel railing. And in the construction you can actually choose the baluster placement. So if I click edit, you will see that there is a baluster pattern and the baluster family is set to none. If I select the drop down, this will look to the loaded families within the project. Baluster square 20mm, click OK, click OK. You will then see that it has then now started to position the baluster. So this video is all about creating a custom baluster. So what I want to do is create a steel post with a base plate that's anchored into the concrete slab. To do that I need to create a new family. So I'm going to go and I'm going to save this project. Let's save it to my folder. I'm going to replace the one that I've already got existing. So I've got a custom steel baluster project. So I go file, I'm going to go new, I'm going to create a new family. Now this will direct you into your program data, your Autodesk files, the templates and English, and you will see that you have 3 baluster templates already existing. I'm going to use the one that's already there. The only difference between some of these is the baluster post has a default height already included. So I click open and you will see that it already has a parameter already set for the baluster height. So I'm going to go file, save it as a family. I'm going to call it a bolted steel post. So in here I want to create sort of a, let's say, a 75 by 15mm steel post with a 150 by 150 base plate that's bolted down. So I'm going to go to my reference level. I'm going to put in some reference planes to control the size of the actual baluster post. You could do this as a fixed size, but I like to build everything parametric. So I'm just going to put in a reference plane here, and then do the vertical ones as well. So I'm setting out a grid pattern, and then go to annotate and aligned, and I'm going to align the reference planes here and here. The scale's a little bit big for me, so I'm just going to change it to 1:2, and then I'm going to annotate this and this. So this one here I'm going to equalize the dimension, and I'm going to repeat the process and annotate these 3 there, and then the 2 outer. Again, I click the inside dimension and equalize it. So now what I have, I've set out the reference planes. I'm going to select the dimension on the left and click on the label dimension, create a parameter, and I'm going to go post width. Again, you can choose whatever you want for this. So post width is there. I'm going to check my family type, and you will see that I now have the post width, and if I set that to 15, the reference planes you will see are adjusting to suit. So again, this is sort of flexing the parameters to make sure that everything is working as we want. I'm going to repeat the process at the top. I'm going to create a new parameter label. I'm going to say post depth. Again, just quick flex of the parameters. Post depth, I'm going to say 75. Select OK, and now we start to have the reference planes moving. So in the reference plan view, I'm going to go to create. I'm going to create an extrusion. I'm going to choose the rectangular draw method, and I'm going to leave the depth as is, and then I'll adjust it in one of the elevation views. So I'm going to snap to the intersection of the reference planes. and I'm going to lock each of the sides into position, and then I click the green tick to finish the edit mode. If we look at it in 3D, you will see that I've created a very simple straight extrusion. If we look in the front view, you will see that there's the extrusion. If we go to the left view, it actually shows the parameter for the baluster height. So this is the left view, so I'm going to select the extrusion, drag it using the shape handle, and drag it up till it meets the baluster height reference plane, and I click the lock. I like to just drag the bottom one up and down again so I can just lock it back into position. So now when we look in 3D, if we open the family types, and if we start to adjust the parameters, baluster is now starting to adjust. So I'm just going to set it back to 75 or 750, 15 and 75, click apply, click OK. So that I've now got the baluster post working as I want. I'm now going to concentrate on the base plate. So for the base plate, I'm going to set out some more reference planes. So I'm going to go to create reference plane. I'm just going to create a reference plane over here and then here, making sure that everything is horizontal and vertical. So something like that, where I'm setting out another grid pattern. I then go to annotate and select 1, 2 and 3, and I do the same on this side, and then I just select the outer parameter. So I'm going to follow the same principle as I did before, where I'm going to select this dimension and equalize it, again select this and equalize it. So this and this are going to be the base plate width, and now you can see that they're now starting to control. So if we look at this, what we want to do is create another parameter that can control the base plate width. So if we just flex it, base plate width, and we say 150, select apply, select OK. So this is going to control the base plate width. On the left view, what I also want to control is a height for the base plate. So again, I'm going to go to create and create a reference plane along the bottom, and this time I'm just going to name it. I'm just going to say top of base plate. So now I've got the reference plane in position. I'm going to go to my reference level and I'm now going to create the base plate. So again, I go to create extrusion. I'm not really that worried about the height because I will drag and drop it into the reference planes. So I'm going to select my rectangular draw method, select the intersection points, and once again lock the parameters into position, and then we click the green tick. If we look in 3D, you will see that we've got obviously the baluster and then the base plate, but because I left the depth at 250, it looks a little bit strange. So if I go to my left view again, there's the base plate, and what I'm going to do is drag that down till it meets that reference plane, and then I lock it into position. I then go to annotate and I select, use tab to select the reference planes, and I control a little dimension there, and I'm going to select it and then add a parameter. Base plate height, could be depth of base plate, thickness. I then select the baluster. Because I locked it to the bottom, I'm now going to lock it to my new reference plane. It will tell you to remove the constraints, so I do that, and then I'll lock the new one into position. If we have a look in 3D, we now get a base plate, and that base plate will be controlled by a parameter. So if we say that the base plate's only 12, you will now see that it's now starting to adjust. So if I said it's a 50mm base plate, so if we just leave it at 15, you'll see what's now starting to happen. So I've got a base plate, and now I've got the baluster post. So next I want to, just for representation purposes, I want to show a little the head of the anchor as such in the base plate. So again, I'm going to go to create and a reference line, and I'm just going to draw some reference lines in here. So these are going to be used to position the anchor in relation to the outside of the base plate. I'm going to annotate them so I can actually control them with a dimension here and here, and then I'm going to select both, OK. You'll see they are now adjusting, and if we use the parameters to adjust, we can then say they're 25 from the edge, and that will get me the intersection where the anchor needs to be positioned. So I'm just going to mirror these around. Sometimes you can just mirror the object, but I like to just put everything into position that I need, and I'm going to mirror these across. And again, I'm just going to annotate these into position. There's a little bit going on in this family, but if you just follow the steps, you'll see the principles are nice. So I now just link these to the previous parameter. So these are going to be the anchor distance. So now I've set these out, I'm just going to go to my left view again. I'm just going to put in a little reference because the sort of visual style I want to show a little washer, then a nut, and then a head of the anchor. So I'm going to create some very simple reference planes here. So I'm just going to create 3 in all, and this one I want to be 2 millimeters. This one I'm going to just drag down because I probably want that to be about 5.5 is good, and then we can just go with something like that is okay. So I'm just going to label these because it's easier to. So this is going to be the top of the washer. So this is if I ever need to go back into it, I can just see what exactly these mean. So these is the top of bolt. Say that's the top of the anchor. So in here I'm going to draw a very simple. Now the more modeling experience you have, the more you can go and create really detailed, but I'm just going to keep this very simple. So I'm going to find the intersection point, draw a circle, and I'm going to say that that is 6 millimeters. Click OK. Now I didn't set the depth, but when you look in the left view you will see that that is the actual component that I've created, and then I drag them in to meet the reference planes, and they just get locked into position. So this is the little washer section. So I'm just going to drag it down, zoom in so you can see what you're doing, and that will do that. If we look in 3D, we rotate it round, apply a shading, you will see that it's just a little washer on top. So back on the reference level, I'm just going to mirror that across to there, and then mirror it again to here, and then again to here. If we look in 3D, you will see that we now have the 4 washers. So let's look at the actual nut. So I'm going to go to create extrusion, this time choose a inscribed polygon. I'm going to say 7 sides, and I'm just going to do something like that. You'll see in 3D there's the nut. If we look at the left view again, it's the same process of dragging the top and bottom, and then we lock them into position. So I drag it down a little bit and then zoom in for further clarity to there, and again, once again, that is locked. Go back on the reference level, so I will mirror that across to here, to here, and then to here. And if we have a look at our 3D view, you'll see we're now starting to get a little bit more definition on the anchor. And then just to create the little anchor coming through, so again, find the center point, and we'll do something like that. Again, back to the front view, you will find the extrusion, drag it up, and then lock it into position. And then back to plan view, and the same process of use the mirror tool to mirror them around. And there you have it. So a very simple post. You can get more creative and create lots of different types. So I'm just going to select these and just apply a material. So just when it does come through, let's go with an aluminium. And we load that into the project, use the render appearance, click apply, OK. And then finally I just want to create a family type. So I've got everything preset. I'm going to create a new type. I'm going to say 75 by 15. Okay, so that has got everything set. Click apply, click OK, and then I'm just going to load it into my project. So this will load it in, and if we have a look in 3D, so once the family is now loaded, you will see under the railing section you've got a bolted steel post, and there's my instance type. Now that it's loaded into the project, we can click edit type, and we can now get to work and start to create something that looks a little bit more like what we expect to see. So if we go to baluster placement, instead of selecting the regular family, we select the drop down, and we will have our new steel post, and I'm going to say that these are going to be 1 meter apart. Click apply, click OK, apply and OK, and you will now see that our bolted post is in with our anchors, and everything's now starting to come into play. So what we want to do is create a top rail. You will see that the current rail on the top is set to be a rectangular 50 by 50. If we look down at the profiles, you will see that there's a rectangular handrail, and then we have a 50 by 50. Beauty of Revit is we can select it, we can duplicate, we can say 75 by 15, and then we can right click, actually just rename it, so I'm going to get the naming convention exactly as per Revit. I can right click it again, go to its type properties, and I can change the height of 15 to 75. So now that I've configured this, I can add that in the edit type, and onto the drop down for the top rail I can go duplicate, and I can say that this is going to be 75 by 15, and then I change the profile type, and there's the new one I've just created, and the material and the finish for this instance is going to be aluminium again. Click OK, click apply and click OK. So now we have a top rail, and we've got the balusters in between. So now what I want to concentrate on is the individual rails. So I go again, I select my object, edit its type, and we just look at the balusters once again. So I've got a baluster here. I may also want to put a start and an end post, so I can go start and end, and I'm just going to set these 100 away from the end. We click apply, click OK, apply and OK again, and you'll see that we now have a post at the start and the end. You can configure it that you can put in the corner, so you can put in a corner post. In this one I'm just going to leave it as is, and what I want to concentrate on is the non-continuous rail structures. So if we click in here, you will see that this allows me to add in intermediate rails. So if I click insert, you will see that I've got new rail. I'm going to go rail 1, and I will choose a default profile, but if I set this as a height of say 150, let's just apply and OK, and let's see what happens. You will see that it puts an intermediate rail in here. But if we select the railing again, let's go to rail structure, and this is where we can actually choose the profile. So we select the pull down, you will see that I have a rectangular handrail 75 by 115, but I want to just do something a little bit different. I want to go with say a 50mm intermediate. So again I find the handrail and I duplicate it, and this time I say that this is going to be a 50 by 15. I then look at the type properties. You'll see that I've got a 50 by 15, change the value, select OK, and then I can start and edit its type with the rail structure, and this time I change it to show the 50 by 15, and I change its material to aluminium just to match everything. So that is rail 1. I'm then going to, once I've got the configuration for 1 with the profile set on the material, I'm going to duplicate, and I'm going to put 5 in, let's say. So I'm going to go, this is going to be rail 2, rail 3, rail 4, and then let's say rail 5. So in here I'm just going to put just a spacing of 150 between them. This is going to be 600, 750, select apply. So now I've got 5 rails coming, select OK. Because the profile is now correct, we go apply, we go OK, and you'll now start to see that we have our a really decent looking, just a quick steel rail. The baluster makes all the difference when it is bolted, and then it's just a matter of following through the options, exploring what you can do. So within a couple of minutes, adding the custom baluster with the bolting and plate details just starts to bring a lot more definition to your railing. So thank you very much for joining me. I will be back soon with another video.